Welcome to the deep dive. Today we're going to do a statistics speed run. You know what you're thinking. It's statistics, really.
Yeah.
But it's more interesting and relevant to your daily life than you might think. And you probably use it more than you realize.
Hmm.
Like, you ever wonder how those targeted ads seem to know exactly what you're thinking? Statistics.
Hmm.
Or how scientists figure out if a new medicine actually works. Statistics again.
Right.
We're joined by a fantastic expert who can help us break down this often intimidating world. Welcome to the show.
Thanks for having me. I'm excited to dive in and show you just how cool statistics can be.
Okay, so let's start with the basics. We're bombarded with data every day. News, social media, even just figuring out what to wear based on the weather app.
Mhm.
Statistics is all about making sense of this data deluge. One of our sources defines it as the collection and interpretation of data, which is used all around the world to understand things like why people have different heights, weights, hair color, food preferences.
That's a great way to put it. It's not just about crunching numbers, it's about using those numbers to understand the world around us. Like, why do some people love spicy food while others can't handle even a little bit of heat? Statistics can help us explore those kinds of questions.
So it's like being a detective, but instead of clues, we have data points, right?
Exactly. And just like a detective, we have different tools and techniques for analyzing those clues. That's where descriptive and inferential statistics come in.
Okay, let's unpack those. What are descriptive and inferential statistics, and how do they differ?
Descriptive statistics is all about summarizing and presenting data in a way that's easy to understand. Think about those infographics you see online, or even just your professor telling you the average grade on the midterm. They're using descriptive statistics to paint a clear picture of what the data shows.
So it's about taking a big pile of data and making it digestible, right? What about inferential statistics?
Inferential statistics takes things a step further. It's about using data from a smaller group called a sample to make predictions about a larger group, the population.
That makes sense.
Yeah.
So for example, if a company wants to know what consumers think about a new product, they don't have to ask every single person. They could just ask a carefully selected group and use inferential statistics to get a pretty good idea of what everyone else thinks.
Exactly. But it all comes down to getting a representative sample. If the sample isn't representative of the whole population, our conclusions might be way off.
That makes sense. It's like if you only asked your friends about the new product and all your friends are just like you might not get a good sense of what people who are different from you would think.
You got it. Now it's important to remember that data comes in different flavors. We have quantitative data, which deals with numbers, and categorical data, which deals with putting things into categories.
Okay, so like if we're talking about a basketball team, their heights would be quantitative data,
Hmm.
but their jersey numbers would be categorical, right?
Perfect example. And just like with statistical approaches, there are different types of categorical variables, ordinal and nominal. Ordinal variables have a natural order like rankings or letter grades. Nominal variables don't have a logical order. They're just different categories like colors or types of fruit.
So my obsession with ranking everything from movies to restaurants is actually statistically valid. I knew it.
It depends on what you're ranking, but yes, ordinal data is all about order and ranking.
This is starting to feel a lot less intimidating. So we've got our statistical approaches, descriptive and inferential, and we've got our types of data, quantitative and categorical. What's next on our statistics speed run?
Let's dive into how we actually analyze that data and draw meaningful conclusions. And for that, we need to talk about probability.
Okay, probability. That sounds a bit more complex, but I'm ready to dive in. All right, so we've laid a good foundation with the types of data and different statistical approaches. Now let's dive into how we actually analyze that data and draw meaningful conclusions. You mentioned probability. That's where things start to get really interesting. Like, I know probability is involved in things like weather forecast and winning the lottery, but how does it fit into the bigger picture of statistics?
Great question. Probability plays a crucial role in helping us move beyond simply describing data to making predictions and testing hypotheses. It allows us to quantify uncertainty and understand the likelihood of different events occurring. For instance, imagine you're a scientist developing a new drug. You test it on a sample of patients and observe positive results. Probability helps determine whether those positive results are actually due to the drug's effectiveness or just random chance.
So probability helps us figure out if those positive results are a real effect, or just a fluke, like winning a coin toss 10 times in a row. But how do we actually use it in practice?
That's where hypothesis testing comes in. Let's stick with the drug example. You'd start with a null hypothesis, which is the assertion that the drug has no effect. Then you'd collect data and use statistical tests to see how likely it is to get those results if the null hypothesis were true.
Okay, so it's like we're playing devil's advocate,
Mhm.
assuming the drug doesn't work, and then seeing if the data can convince us otherwise. But how do we decide whether to reject that null hypothesis?
That's where the p-value comes in. It's basically a measure of how likely it is to observe your results, or even more extreme results if the null hypothesis were true. The smaller the p-value, the stronger the evidence against the null hypothesis.
So if the p-value is really small, like say less than 0.05, it means it's very unlikely we get those results just by chance. So we can reject the null hypothesis and say, hey, this drug actually seems to be doing something.
You got it. That 0.05 threshold is a commonly used benchmark in scientific research. It means there's less than a 5% chance of getting those results if the drug wasn't actually effective. But it's important to remember that there's always a possibility of error.
Wait, so even with all this statistical rigor, we could still be wrong.
Yes, there are two types of errors we can make in hypothesis testing: type I and type 2 errors. A type I error is when we reject the null hypothesis when it's actually true, like concluding the drug works when it really doesn't. A type 2 error is the opposite, failing to reject the null hypothesis when it's actually false, meaning we miss out on a potentially effective drug.
Wow, so there's always a trade-off between those two types of errors. It's like walking a tightrope.
Exactly. It's all about carefully considering the data, choosing an appropriate significance level, and designing well-controlled experiments to minimize the risk of both types of errors.
This is making me realize that statistics is a lot more nuanced than I originally thought. It's not just about crunching numbers. It's about understanding uncertainty, probability, and the potential for error.
You're absolutely right. It's about using the right tools and techniques to draw meaningful conclusions from data and make informed decisions.
This has been so insightful. I feel like I'm starting to see the world through a statistical lens. We've talked about data types, statistical approaches, hypothesis testing, and even the possibility of errors. But there's one thing I still can't shake: the idea that statistics can be manipulated or misinterpreted. It's like that old saying, there are three kinds of lies: lies, damned lies, and statistics.
That's a very important point. Statistics can be a powerful tool for understanding the world, but like any tool, it can be misused. It's crucial to be critical consumers of statistical information, to question the source of the data, the methods used, and the potential for bias.
So it's not enough to just blindly accept numbers and figures. We need to think critically about where those numbers came from and what they really mean.
Absolutely. The more you understand about statistics, the better equipped you'll be to spot misleading claims and make informed decisions based on data. It's about becoming data literate so you can navigate the information landscape with confidence.
This deep dive has really opened my eyes. I'm starting to appreciate how statistics shape so many aspects of our lives, from scientific discoveries to everyday decision-making.
Me too. It's exciting to see how this field is constantly evolving and influencing our understanding of the world.
This has been such a fantastic conversation. But before we wrap things up, I want to touch on something that's been on my mind throughout this deep dive: the role of statistics in our increasingly data-driven world.
That's a great point. We're living in an era where data is being generated and collected at an unprecedented rate. From social media to healthcare to finance, data is transforming the way we live, work, and interact with the world.
It's like data is the new currency, and statistics is the tool that helps us unlock its value. So what does this mean for us as individuals? Why is it so important to understand statistics in today's world?
Well, with all this data comes the need for people who can interpret and use it effectively. Statisticians are in high demand across a wide range of industries. And even if you're not planning to become a statistician, having a basic understanding of statistical concepts can be incredibly valuable in almost any career.
So it's not just about being a data scientist or a researcher. Understanding statistics can benefit everyone, regardless of their field.
Exactly. It can help you make better decisions, solve problems more effectively, and even spot opportunities that others might miss.
It's like having a secret weapon in a world overflowing with data. We've covered so much ground today, from the basics of data types to the complexities of hypothesis testing and the importance of being critical consumers of statistical information. So as we wrap up this deep dive into the world of statistics, I think our listeners are walking away with a much better understanding of not just what statistics is, but why it matters so much.
Yeah, definitely.
One thing that keeps coming to mind is that statistics is often presented as this cold, hard set of facts. But as we've discussed, there's a lot of nuance and interpretation involved.
That's a great observation. It's crucial to remember that statistics is a tool, and like any tool, it can be used in different ways, sometimes even misleadingly. One of our sources points out that Statistics can be defined as the collection and interpretation of data, highlighting the importance of that interpretation aspect.
So it's not enough to just look at the numbers. We need to understand the context,
Yeah.
how the data was collected, what questions were asked, and even who's presenting those numbers and why.
Exactly. Think about those ads you see that claim 9 out of 10 dentists recommend this toothpaste. It sounds impressive. But did they actually survey a representative sample of dentists, or was it a small biased group? Always dig a little deeper and ask those critical questions.
It's like being a statistical detective looking for clues that might reveal hidden biases or misleading interpretations. Do you have any tips for our listeners on how to spot those statistical red flags?
One common red flag is cherry-picking data, where only favorable data points are highlighted, while inconvenient ones are ignored. Another is manipulating the scale of graphs or charts to exaggerate or downplay trends. And of course, correlation doesn't equal causation. Just because two things happen together doesn't mean one caused the other.
Those are great points to keep in mind. It's like having a statistical toolkit to help us navigate the data deluge and avoid being misled.
Precisely. The more you learn about statistics, the more tools you'll have in your toolkit. It's an ongoing process of developing your data literacy so you can make informed decisions in all areas of your life.
Well, this has been an incredibly insightful deep dive. I feel like I've gained a whole new appreciation for both the power and the potential pitfalls of statistics.
Me too. It's been a pleasure sharing my passion for this field, and I hope our listeners feel inspired to keep exploring the fascinating world of data.
A huge thank you to our expert guest for guiding us through this statistical speedrun. And to our listeners, keep those statistical gears turning, stay curious, and never stop questioning the numbers you encounter out in the wild. Until next time, this is The Deep Dive signing off.